Okay. Hey, what's up, Remo? Can you guys hear me? Just double checking if everything's working right now. Okay, just trying to get the pop out chat. So what we're gonna do today is we're gonna design a new board. Just give me a second to fix everything here. 'Cause I have something's wrong with YouTube. I can't pop out the live chat. So I thought I'd do a question and answers today, and also at the same time, going to be developing a board like this one. Now, some of you probably missed this. What this is, it's actually a USB interface for Arduino. And what I was able to do back then in one of my videos is show you guys how to basically fly any quadcopter with like a PlayStation controller or even a PC joystick. So what we're going to do today is we're going to develop a dedicated board just for that. We're going to be using this. What's really nice is this is basically also open. The schematic is open. I have it open in that bottom left on the screen. I think you guys should be able to see it, the schematic there. So we're going to start off this one. This is the exact one right here. And what that allow you to do later on is plug any module, for example, a TBS Crossfire, and install a USB here to whatever joystick, and you can fly whatever you want. For example, a multi-protocol module will allow you to fly anything, like even the toys. So I just thought I'd do a question and answers, just chill with you guys, and at the same time, just start doing this. So right now we're gonna start. I don't think we'll be able to finish it today, but we're gonna get as far as possible because I've been wanting to do this for the longest time, and just this is the right time, I guess. So right now we're just getting in the chips that we need, which is this right here. This is the USB host interface. These are the hex converters or something like that. And then we have our little crystal oscillator, the USB type A, which is this guy right here. Let me just see how you guys are seeing the stream here, just double checking. Sorry about the green screen. It's just, I'm just not going to deal with it right now. So right now what we're looking at is that red piece that's glowing on the left side right there is going to be the type A female here, which is exactly this board, but we're going to do it in a different layout again. And the crystal is this little, well, it's going to be so hard to show you guys. It's this little thing right there. And these two ICs are the hex converters, what we see on the right, and the main chip right there, which is in the middle right now. And we have its schematic, this exact board schematic up on the screen right there, right next to me on the opposite side. So we're just going to just basically copy that. And then once we have the schematic done for this, then we do a basic schematic of an Arduino basically within one board. And then later on we do the PCB designing to make it modular so it could take the FrSky modules basically. So it's going to be really fun, really interesting, and everything obviously is open source and open hardware, especially for my Patreons. They're going to have, immediate access to all this stuff. So that's what we're going to be doing. Good day, Spartan. Yeah, you can do that, Vitroid. You could control it with a keyboard too. You just have to set that up yourself. I did a pretty good tutorial on that for the PlayStation 3, I think, PS3 controller. I have a PS4 controller right here, which we'll be testing later on. But it's pretty interesting because what this will allow you to do is, especially if people are handicapped, be able to build those joysticks for the jet fighters and be able to fly with that, which would be really, really good here. I have no idea how many people are viewing, so I'm going to ask you guys because my screens are full right now. All right. So right now what this is, the main IC is going to need 3.3 volts. So we have the regulator here, and I pulled this regulator from my open hardware flight controller, the F4. We're going to modify this later on, but I just placed it here. It's kind of like a module, so I just stuck it there. I'll work on it later. But right here like this, we have 3.3 volts. And I should actually change VDD to 3.3. 3.3. There we go. So this way we could always reference it, and it'll automatically tell us that it should be connected to here once we start the PCB design. If you guys have any questions or anything, also just feel free. I'm watching the chat also at the same time. Right now we're gonna need to give VL. If we could take a look at the schematic here. Where is it? Let me just pull that up for you. I think I should zoom in a lot so you guys can see everything. So right now we're gonna start with this chip, which is exactly this chip right here. And we can see that VCC and VL are connected to 3.3 volts. We also have the initialized right here, which is gonna go to a 2.2 K resistor. So we're just basically going to copy this whole schematic and then later on incorporate the Arduino schematic and then just have it into one nice board, which is going to be really good, especially having this schematic being open source. You'll be able to design your own variant of the PCB, which will be very useful. It'll be just basically like a template and you just fill it in like a puzzle, and probably stream that also later on. And you guys could ask questions along the way. So right now we're going to bridge VCC and VL like the schematic is showing us there. So I'm not trying to reinvent the wheel here. So if there's an easy route, we're just going to take it. And obviously everything here is open source still. So we're going to just do this. So basically this means VCC and VL are connected and just double checking. Yep. And that's going to go to 3.3 volts. So what I'm just going to do is, I'm going to grab this. And I'm just going to place that right there. So now we know this 3.3 volts for those two pads right there. 22 people, nice. That's awesome. I was expecting probably 10 or 9 to 10, but that's really great. So here we see the D plus and D minus. This is going to go to this right here, which is the USB connector, which is this female right here. And again, if anybody just joined in, we're doing the schematic of this board that I found online. And I've used this again in previous tutorials, which will allow you to control your, control basically any module with any type of USB interface, from joysticks to PS4 controllers, Xbox controllers, but I wanted to make a dedicated board for that. And here I pulled up the schematic, which you can see on the bottom left side of the screen here that we're copying currently. Yo, I'm building the Diatone 548 from what you're building. Could you tell me please how to set up Betaflight and the settings? Well, I have a Betaflight setup, which basically should cover most of everything there. I've done so many build videos, I don't remember which one that is. Maybe, is it the one with the T motor? The Popo T motors? Would it be possible to run? Yes, it is, but there's a couple things you need to take into consideration to do that. So Vitroid is asking, would it be possible to run multiple external modules off one radio? Yes. However, the way to do that is, because there's two types of ways to do this. One is that your controller would be sending a PPM output to this. And then the other one would be a serial communication protocol. For example, if you go into the multi-protocol module settings in your FrSky, it'll allow you to choose FlySky, FrSky, and whatever it is. And that's using a serial protocol. However, there are some modules that are also multi-protocol, but they have a little notch right here that you choose it. Basically, you dedicate what frequency to be on or what protocol to be using. And that is what will work. So that would have a PPM output. So if you're outputting PPM and the modules take PPM input, then you'll be able to do that. Also, probably the serial RX, but you're going to have them all be the same. Sorry about that, guys. Yes, the Popo T motor. I do have it somewhere here. I'll grab it in a little bit, and I'll probably dump the Betaflight for you. And then you could just take it and copy it. And then hopefully if you do the exact same thing, then everything should work. Thank you, Spartan. That's really nice of you. That actually made my day. All right, so let's see what's next. So we got the power. Let's do the grounds. So we have two grounds, which are these two. We're going to bridge them like the schematic says over there. All right, just grab a little ground one here. Bam, right there. Awesome. We're making progress. One step at a time, you'll finish anything. All right. Thank you, Vitroid. Okay, so next thing down the line. If you guys also have any questions while you're watching, just feel free to ask also. Why am I doing something? I don't know everything, but I'll do the best as I can to help you understand what I'm doing. Thank you, Remo. Thank you, guys. All right, so we're gonna ignore all these GPIOs. Those are those. This is this side of the chipped IC. is going to be the thing that's going to be connected to the Arduino, which is also going to be built into this board, which we're going to get into later on, because I actually don't even remember how I did it. I have to go watch my tutorial again and remember what was connected to what, because this is a USB host shield for Arduino. So we're going to come back to that later. But we can see the X0 and X1. This is where the 12 megahertz crystal or the oscillator is going to be, right here. Now, I don't even know if I got the right one, but, you know, we'll double check it. Worst case scenario, what I do, especially if I'm doing something like this, like I'll have the hardware version of it. For example, the flight controllers. When I first designed my open hardware flight controller, the crystal, because some of them have capacitance, you know, like 12 picofarads or something, and I had no idea which one was being used into the F4. So what I did is I designed it to be the same size or the footprint as the ones that are currently found on whatever's in the market. So worst case scenario, from the ones that I bought, if they don't work, then I could just take one of those off and stick it on my open hardware flight controller and see if that works. So I'm doing the same concept here. I don't know if this is the correct one, but usually they end up working just fine. But just in case, it's always like a backup, because it'll be an absolute pain in the butt. Redesigning that wouldn't be so hard. Ordering it, you lose a little bit of money, $10 or so. It's not a big problem. But the biggest problem when this happens, especially if you're building this again all over again, you're reworking this, you have to take all the components off and put them on the new board, and that could get really annoying. And that's, you know, sometimes it'll make you like almost quit because it takes so goddamn long to do. Hi, Flown. All right, so let's go ahead and connect our crystal here, and just double checking. So we can see the crystals connected on X0 and X1. And I am going to connect. Should we do that one, or should we skip it for right now? This has 4 connections, so we got the 2 together. 1 and 2. I think we're gonna come back to this. I'm just gonna double check because this has the 4 pins. Might have to trace them. Maybe not. Just double checking a couple things here. Only one-sided. Those are not connected anywhere. So we just basically connect 1 and 3 right now. All right, so 1 and 3, where are they going to go? We have, okay, so it's using an 18 picofarad capacitor and 2 18 picofarad. Well, actually, we're just going to come back to this one because it's going to be a little bit of a mindfuck, and I haven't warmed up enough yet. Okay, let's put this to the side. Let's do our little USB connection. This is the USB type A female here. A female USB. The current design, Nick, it's basically an interface that allow you to connect you know, the modules that go on the FRSky, and you'll be able to basically control any quadcopter with some sort of a USB interface, like a joystick, a PC joystick. So you'll be able to fly anything, even if it's using the TBS Crossfire. You'll be able to put the Crossfire on this thing and be able to fly your quadcopter with a PlayStation controller or whatever PC joystick you would like to use. And I've done a tutorial on that before, but I really want to design it all into one board. Plus, I don't have to reinvent the wheel because the schematic for this board is open. So we're going to just copy that, and then we're going to add an Arduino into the schematic, and then later on design it as a complete package one board, and in a nice way where you could actually plug these modules just right in. And I think it would be a really fun little project, and yeah, I just wanted to do it, and I think it's very useful. The reason why I get more motivation to do it is for people who might be disabled and, you know, maybe don't have use of the right thumb or something and need a joystick. They'll be able to use that also for such thing. You know, they've always wanted to fly a quadcopter, and what's really nice is with the multi-protocol modules, they work on any Chinese product. So you'll be able to basically fly anything in the market, especially with those multi-protocol modules. So it's really good. I think it's really great. There's a lot of benefits to this, you know. And if you guys have any questions, obviously, go ahead and just let me know. Like a robot, try an ESP32. Right now, an ESP32 doesn't have it. This is a USB host interface right now. So we might use ESP32, but I think I'm going to go with the basic route of just an Arduino setup because I've tested that and I know it works. And I haven't really tested it with an ESP32 yet. Eventually, I'll probably do it because it's really nice and small. But I've never done the designing or the schematics of an ESP32. I've done Arduino before, you know, the AT Mega ICs, so I'm familiar with that. So I want to stick to something I'm familiar with, so I have a higher probability of succeeding on my first try, because I don't want to have to do this more than once, really. Okay, so fly, not sure why USB, but if it's what you want to do, engineer up. Thanks, buddy. I've done a video on this before. Maybe I should have linked it below. All right, so let's go ahead and do this. So we got D plus and D minus are gonna go to a resistor, and then they go to the chip, and there's a 33 ohm resistor here. So let's go ahead and set that up. All right, so we're just gonna do 2 wires here. Here's 1, and here's 2. And we're gonna go ahead and grab some resistors. Here's a resistor. We're gonna put 1 resistor and another resistor here. Make this a little bit nicer. So it's a 33 ohm, not a 1K. This is very useful to always modify these right as soon as you put them, because you can easily screw up here. And then we'll do another wire. Instead of connecting them directly to the IC now and getting this all cluttered, what I'm going to do is I'm going to make these little bridges here, which are, they're basically called net labels or labels. And we're just going to go ahead and just do this like that. There we go. And another one, same concept here, like this. And then we can just, I'm just going to grab this one. Okay, I'm going to call this D plus. Beautiful. All right, and then we're going to take another one. D. Okay, and this would be D minus, which is the data lines for the USB. That's what we're looking at here, D minus and D plus. And then we can just go ahead and grab the D minus, and we can grab the D plus. Now, when we transfer this over to the PCB, it'll do all of the pre-routes for us, and then we decide how to route them. And that's why we do this, and it just makes your life so much easier. Once we get into the PCB part, then it'll just be kind of just like a puzzle. You just put everything together and connect them of how it says to connect them, because that's what we're doing here, is the connection setup, basically, if that makes any sense. No, that's not KiCad. This is Easy EDA. I just love using it. It's just so much easier. They have so many libraries. Just the whole community behind it is really great, because even if there's just so many custom libraries for a lot of people have done here, and it just makes everything so much easier. And especially when I share my projects with you guys, especially my Patreons, you guys have access to all this stuff, and you guys can do whatever the hell you want with it. Oh, Spartan, thank you so much. Awesome. Thank you, buddy. And here's my coffee's almost finished right now, but yeah. I hope you guys don't mind if I smoke a ciggy or two on the stream, because I'm going to, and most of you are basically adults here, so I just hope nobody complains. Yeah, I'm using the hotkeys. Yeah, I forgot about that. All right, so let's see. What do we have next? We have VBus. VBus is going to be the 5-volt. I don't know how I'm gonna route it just yet, but we'll just do the beginning part of it. So, you know, everything that's USB puts out 5 volts, because obviously we're going to be powering the joystick from this connector right there. So we're going to have to give it 5 volts. I don't have a 5-volt regulator on the schematic yet, but once we get there, we get there. All right, so what is this doing here? 0.1 microfarad capacitor. That's going to be also connected to ground. So we'll just grab a little capacitor here. There we go. And we're just going to put it like this right now. We're going to say 0. Oh shit. How long have I been muted for? Okay, good. I just noticed that. Okay, sorry about that because the hotkeys and because I'm typing the numbers. All right, I just figured that out right now. Okay, I'm gonna grab ground here. That's not connected. Oh, it is connected. Nice. A little bit smaller. Right there. Okay, so we're kind of almost done with the USB part here to the IC. We're gonna come back for the oscillator, which is gonna be on X0 and X1. The voice should be back now. It's just a little delay, probably. Yeah. The voice is back. Yeah, I accidentally had the hotkey set up to mute my mic, and I just noticed that. Yeah. Sorry about that. I think it was like for 2 minutes. You guys didn't hear me, maybe. No, I don't know what the hell I was saying, but when it was off. All right, let's see. What do we have next here? We're gonna ditch that part, and let's see here. Okay, let's check this out. Okay, the reset. So that's gonna go to a 2.2 resistor. So we're gonna do the initialization here. The int pin. So it's going to be 2.2K resistor up to 3.3 volts. It's on the other side of that. So where is it? It's right here. So we are going to do W. And we're just going to do this. Right? I'll just make it up to here. Oh, shit. All right. Going to add a little resistor. 2.2K. 2.2K. Just double checking. Is it 2. Yeah, 2.2K. I'll bring this in a little bit. Actually down here. Because we're going to need the X0 and X1 because it's going to be really annoying. Especially when we get to the oscillator if we don't have space. And we are going to go to, where is it going? 3.3 volts. So we're just going to grab this. I'm just going to do this. It's going to 3.3 volts. So we finished that. Mossy, Miso, S clock, and SS. Where the hell is SS going? Well, it's all right. We'll do that later then. So we're going to say, we'll just copy this here. Do you have time now to show the beta flight setting, or should I write you? In a bit, I think. Give me a second, real quick. Irvin, do you know we have 2 diatone builds here. The black one with the T motors. Is it by you over there inside? It's either by you or it's gonna be back here somewhere. No, not the little one, the big one. It's a big old one. It's one of the 5-inch ones. Hold on, Remo. We're gonna see if we can find it real quick for you. But I don't know if I'll be able to connect it right now, but I'll have it next to me so I don't forget. By the way, what is the thing you're designing? Sorry, I just joined. The thing, that one, yeah. No, the other one, yeah. Okay, so this is the one you guys are talking about. Okay, so what I'm designing here is basically a USB interface for joysticks, and what it'll allow you to do is bring you like your TBS Crossfire, connect it to it, or a multi-protocol module, connect it to it, and then you'll be able to connect any joystick you want, like PlayStation 4, PC joystick, and fly whatever the hell you want with it. So that's what we're doing here. We're designing it into one board. I've done a tutorial previously on how to use this USB host shield, the Arduino, and how to program it, but I want to design just a dedicated board for that specific task. There's many use cases for it also. Just Mr. Flamenco, just jump right into it. That's it. Just do it. That's what I did. I just put a project in my head and I went for it. And if it works, it works. If it doesn't work, keep trying until you get it to work. But I don't know. Really hard. Design some really basic stuff first, like maybe an LED sign or something, and from there just work your way up, and eventually you get something really nice. Like, for example, figure out how transistors work, maybe, and then create a little pit mode board that allow you to go into pit mode, turn off the video transmitter, and stuff like that. You could design really crazy cool things that just take a couple components. Okay, so let's go ahead and continue here. S clock meso mosi. All right, let's just go ahead and just route those directly, just like that, that, and I don't know what the hell SS is just yet. So we're just gonna escape. We're gonna copy this guy, set him up here, move him a little bit, and just name him. Okay, mosi. So this is, I think, one of the most time-consuming parts. Right after the PCB design. The PCB design can get really annoying, especially if you're only sticking to 2 layers. But this one shouldn't be that complicated, I'm hoping. But adding the whole Arduino circuit with it is going to be a little bit of a hassle, really. Are you a fan of Bantam desktop mill? I've never heard of that. I have no idea what the hell that is. Awesome. Yeah, I wish it was a bit more detailed. Flamenco. Is it Flyminco? Flyminco, Mr. Flyminco. I'm just gonna call you Fly. All right. So what's next on our list here? Ground, we did it. Let's go and tackle the 18 picofarads, 18 picofarads. So right now what I'm going to do is I'm going to tackle the crystal, which is this one, 12 megahertz. Oh, it's not crystal, oscillator. Sorry about that. I know some people are going to give me probably shit for that. So we're just going to do also a route there because I don't want to bring it in too close and just make it all cluttered here and very hard to understand. So we're just going to keep it pretty simple, or try to keep it clean. That's the word. That's the word I'm trying to go for. X1 and X0. And then here we do the same thing. Grab one here. Grab them, connect them right now. Okay. The wire, where is this one going? This one's going. Okay, that's going to ground. That side's going to ground. The other side's going to 0. Okay. All right. Sometimes it's a bit of a, I don't want to say the word. Martin Phillips, you're welcome, buddy. Thank you for joining the stream. Okay, so we need 2 18 picofarads. So we're just going to do this one step at a time. So we're going to go ahead and grab the oscillator part here. That's the shell. Okay, hopefully you guys are seeing what I'm seeing. Okay, so we're going to go and we're going to hit one side, which is XO. So we're going to hit XO real quick. Okay. There we go. Come on. All right. We'll just connect. Figure it out from there. We'll start with X0. This is the oscillator part, and outside we have the ground shield of the oscillator. It's that usually that thing that looks like a barometer on the flight controllers. If you guys seen it, we have a 8 megahertz oscillator on our flight controllers. It's like a silver thing that's shiny. And if you really like get a magnifying glass and look close, you'll find that it says 8 megahertz. I think it was 8. Was it 8? I think it was 8. I'm sure it was 8. 8 or 12, I forgot. Oh, I have my flight controller right here. Oh, let's see my schematic. It's 8. Yeah, I was right. See, 8 megahertz. Yeah, I was right. It's been so long since I've touched up on this. I really need to get my I might live stream the F7 flight controller open hardware design if this is really great. If you guys are having fun here, I might actually do that. So maybe I might stream a bit more often. Because I've been wanting to, but it's just been very difficult to find time because I've been trying to increase the quality of my content more than the quantity like I used to. And I'm still trying to improve right now. I'm still trying to find that the really good sweet spot. A lot of information, and I want to do more testing. And that's why it's taking me much longer to upload videos. I really want to perfect this and give you proper information to make your educated guesses. Hello, everybody. That's awesome. A lot of people are joining in now. Okay, so we need 2 18 picofarad capacitors. All right, so we have we have this connected to one side, which is XO. Okay, so this is XO. It's connected to the side, and it's gonna branch off. It's gonna connect to a capacitor. we're just gonna go from here, and we're gonna go here. Should we copy the same layout? Maybe that'll be less complicated. All right, hit that there. Grab ourselves a little capacitor. Wish these capacitors were a little bit smaller here. What is it? It's 18 picofarads. 18 picofarads. Yeah. And it's going to the other side of the other capacitor, which we still don't have. Ooh, I should move this for you guys so you guys can see everything. Okay. We need one more capacitor here. Place it right here for now. All right. And the other side of the capacitor is connected with the other one. Just gonna do this side connected to this side. And I actually want to do this like this. Okay. And this one is connected to this one like that. What else do we have? I need help figuring out OSD. You know, are you talking about the OSD on the F4 microcontroller unit, the open hardware schematic? I figured out the issue. My schematic was kind of wrong. That's why I never really released it officially. One thing is you got to be careful of which chip you're using. I think the Max, the chip that says Max on it, something, that's a 5-volt chip if I remember correctly. And the Chinese variant, which is called the AT, do I have a flight controller next to me? I do actually. Which is called AT or AF, I forgot. It starts with an A anyways. That one takes 3.3 volts. But it's still, I still haven't perfected the OSD part either because I really never went back and looked at it. I still need to debug the one that I've built. The F7 micro? What F7 micro? Yes, please do the F7, F7 plus 1, awesome. I'm using an online program called easyeda.com. And the reason why, again, I choose this is because it has a really large community. And whatever chip you need, you can usually find, or users have designed it, so it makes your life easier. And again, not only that, when I give the access to my Patreons, they can click and they get access to everything. From the PCB, they could redesign it. And if they screw up, they could just reload it again. And it's really nice because I don't give you a PDF and then you have to redesign it yourself. You get just, you get a copy of it in your own repository kind of, and you can just modify and do whatever you want with it. Change the PCB size, the dimensions of it to fit a specific frame. You can do all kinds of crazy cool stuff. So right now I'm kind of trying to get my hands on a Whoop schematic in a way. I can do it, but if I could get my hands on even like an older variant of the Crazy Bee, I think there should be one out. Then I could I really want to design one. I have one here next to me right now. What I noticed actually something I never really noticed before. For example, with this flywheel, I don't know how I missed it. So usually each phase on an ESC, do I have any ESCs next to me? Well, yeah, maybe this one here, but these are super tiny. Anyways, the Whoop size boards, the Crazy Bee or the toothpick size boards are 25 by 25, these guys right here. What I found out is that usually for motors, you have 2 FETs for each wire. But here, you get 1 FET for each wire, which is it probably like a dual channel FET? I don't know. I haven't looked up the specs, but I'm planning on putting under the microscope and getting the data sheet of these. But that's pretty interesting because you can save a lot of space here. And again, you're not going to be needing more than 15 amps. And I just find that really interesting, actually. Sometimes I really wish I could make videos on these to go really in detail. But the problem is with those videos, they just don't get attention and I lose a lot of people. So it's really hard to get people to explain it in a super simple format where I could try to get everybody to understand it. This is a grab file. It's not a grab file. It's you mean the Gerber? No, you could get the schematic and the Gerber files and you can modify them before and then you download it. Oh, that sounds interesting, Spartan. Yeah, I'll do that. I haven't done a live stream in so long that I've forgotten here. Oh, we have 32 viewers. That's awesome. I didn't even see that. That's great. All right, let's see. Where are we now? So, let's see. Next thing we need. Okay, you guys kind of lost me here. I'm definitely gonna screw up here or there. I'm actually I'll just keep it here right now. Okay, so we got the XO connected. one side of it. The other side is connected to X1. And then we have this is going to ground and the other side going to ground, which is connected on the outer part. Okay, so we're going to take this. Oh, shit. Sorry about that. No. Wrong. Don't screw me over. Okay, so this is going to be going here. And it's going to connect to this one right here. This is the shell, basically. I'm going to drop this like that. We're going to give it to ground. And this side should be also connected to ground, but we're just going to drop it here just to make it a little bit. There we go. That looks proper. I'm just double checking it. So we have X1 connected to this. Okay. Okay. And then it's going to connect to this side of the capacitor. That side of the capacitor is going to be connected to ground. And it's also going to be connected to the other side of the other capacitor. And then the other side of the capacitor is connected to this side of the oscillator and the X0. Awesome. Honestly, I watch you because of the technical stuff. I think you do a brilliant job at that. Thank you. Bye. Thank you, guys. Okay, I'll go back to it. Oh, you're welcome, Justin. No problem. All right, so we got that done with here. 30 people. I'm really happy with 30 people. I was expecting maybe 10 people. So I'm very satisfied, actually pleased that actually 30 people are watching right now. It's it feels nice. It feels really nice, actually. Very grateful. All right, so here we have the what are they called? The hex converters or something? I forgot. Let's see. All right. Okay, so let's see. I'm gonna bring this up on this page here because it's hurting my neck to look on that side. Okay. Okay. All right. So what do we have? ARD. What does it mean by ARD? What is it trying to say? ARD. ARD mostly. Okay. Okay, it's going to that one. And then here. Oh, okay. So this is after. Okay, so MISO would go to this chip, which is the 74HC, and then it gets piped out as ARD MISO, and then ARD MISO is going to go into this one. Wait, and then this is going to come out? Mosey? No, that's Mosey. Where's MISO? Is it MISO? I'm going to call it MISO. I'll probably piss off a lot of people if that's how you say it. Where the hell does that one go? I think I'm going to have to probe this board here later on. I will have to probe this. Oh, there's these little connectors, are there? Not really. Oh, yeah, I see them. Oh, okay, these are like little bridges here. That's what they've done here. Okay, that's what I see here. Okay, we really don't really have to care about them because mine were not bridged when I did my tutorial. So that means it doesn't matter if they're connected or not. Okay. Maybe I don't even need those, to be honest, but we'll just do it anyways. Welcome, Gary, to FPV. If you need anything, just let me know. Do I have a video for intro? I think I did a basic one, but if you guys want, let me get a notepad here. And let me just take some of these notes because, I always tell you guys, if you guys have any suggestions at the end of my videos or anything, let me know, but nobody ever lets me know. So, it's your fault. It's not my fault. I always tell you, what the hell do you guys want to see, because sometimes I lose touch with the beginner side because I've done this for quite a while now and I've seen just about everything. So sometimes I think that you guys know what I know, but I'm actually wrong. So that's why I try to do the connection, how to connect everything and just add a little info here and there for it. Okay, so intro into PCB design. Intro PCB design. I'll think of fun projects when I do this where it's actually useful. For example, I did a really basic one. I just remember it's not really a PCB design, but the race wire. That one was pretty cool. A lot of people used it, I saw. Okay, so intro into PCB design. Let's see what else you got. Thank you, Mr. Fly. That means a lot to me. You must believe in yourself. 3,000 people. Awesome. Thanks. Hope I can learn everything I need to know. Will do. Love your vids. Okay. If you could do a beginner whoop, beginner under $100 whoop. What do you mean by whoop now? There's brushless whoops. There's 1S whoops. There is toothpicks. I think you can do a proper toothpick. You know, the thing is, you actually you don't even need to build unless you really want to build. For example, the Happy Model Sailfly X, okay? Even though it has pretty weak motors, but it is by far one of the most fun I've ever had with a toothpick. It's just really nice. It's $80 and it'll get you going, and it just has a lot of power, and it's just really beautiful to fly. Unlike, I mean, it's not going to be one of those super expensive ones, but you could still enjoy it. It has so much power, so much efficiency. It's really light, and the parts are absolutely drop dead cheap. So, but I'll write that down. Can you build a quadcopter for less than $50? I don't know if you can. I doubt it. Hell no. It's a struggle to try to keep it under 150 usually. But I'll look into it. We'll probably have to mix around between eBay and AliExpress maybe. But now China's basically closed and on lockdown, so good luck getting anything. Even AliExpress, I think, is off. So, but even eBay, even though eBay is not really a Chinese company, but most of the sellers are from China, and all those places are closed, unless they're using Amazon warehouse. But that's gonna basically just sell out really quickly because of the issues right now. Okay, so we're gonna say whoop, budget whoop build. I think I'm gonna go with brushless though. I'm not gonna go with 1S. I don't like 1S. That's just me. All right, I wrote that down. All right, let's see what we have here. Okay, so we could let's go ahead and just pipe meso here and SS to this one right there. So that's what we're gonna do. We're just gonna take it one step at a time and just make sure you guys have everything here. Making sure that screen is good. Okay, I'm just gonna. All right. Okay, I'm just gonna read you guys' comments real quick. Okay, we're just gonna push this here. Okay, that's gonna make my life so much easier to do this. All right. So connecting, explaining on flight control is very awesome. Awesome. To the subject of this video, can you please reply to my email I sent you? Subject: need help with GETFPV. I will check it as soon as I get off the live stream, and I'll write that down right now. You gotta understand, I get so many emails, and I go to reply to somebody, like, and somebody calls me, or I get sidetracked with something else, and then that's it. Basically, that the email's gone. So many times it happened to me. So I need help, GETFPV. Need help, GETFPV. Okay. I will get back to you, hopefully after the stream, if I'm not too tired after it. Yeah, AliExpress is down. Yeah, that would be great. Thanks. I just need to do PCB race wire, but info on everything from the program to design the parts section. I did do the video on that, David. Just check how to make your own LED race wire. I think I did 2 parts maybe. Mr. Fly says, what's your full-time job? Well, right now, this is partly a full-time job, believe it or not. And I also do programming. I do a lot of programming for companies. I specialize in IPTV and OTT systems, which is like, online streaming services security. And I also do Android. I also do Android programming also, or just Android development. And that's really it, I think. I do a lot of the other side things also, but these are basically what I usually do most of the time. Basically, business owner, maybe you would say, because I have everything registered under Drone Mesh Labs. So, it's really weird when somebody asks me, what do you do for a living? It's like, I don't know. I do a lot of things. All right. Exactly. Awesome. All right. Let's see. So we need which chip right now? We need to work on, we're going to start off with the 74HC, which is this one right here. So we're going to work on this one right now. I'm just gonna check how the stream looks like on my phone because I have no idea because all the screens are occupied right now. Just double checking you guys can see and hear everything. Oh, it looks, oh, it's pretty good. I'm very happy, satisfied with how it's coming out. Awesome. Oh, the chats here are kind of blocking you guys' view. Okay, I didn't know that. We're gonna push everything to the right side here so you guys can see everything. All right. Now, I don't know if this is the exact correct chip, but I'm guessing it is currently, and I'm hoping it is. Do you still have the CNC machine? Yeah, I do. And actually, I've been looking at it for the past 3 days, wanting to start videos and tutorials again on it. You know, and when I first uploaded the videos, I think it got okay views, and then the second 2 projects maybe didn't get so much, and then, but it was a lot of, it was very time consuming to do those, and I just thought it wasn't worth it. But now, as time went by, I see that they're still getting views, not like super fast, but they're actually growing in views, and I do constantly see comments on there, so that's really nice. So yeah, I'm planning on doing those maybe a bit more and doing some fun projects. Right now, I'm going to be working on my own toothpick frame. I don't know if it'll go for, I don't know if I'll sell it, but we'll see. Maybe I could collaborate with one of the companies and they can produce it. Like maybe Flywoo. I like Flywoo stuff. They're actually lately, they're really nice stuff. Okay, you guys are distracting me too much. All right, let's see. 74HC, Miso is on 1A1. So we're going to go here. Going to drop this guy there. Let's just do the ones we're going to do. What the hell is 10? I don't have 10 here. Or is it 10 or something? That's not the same chip, is it? Is it Y? No, there are the Ys. Oh, then it's the O's. This is A1, so this is O1. Okay, I get it now. So SS is on O1. We're just gonna call this O1. That's where SS is. Initialize on 2A, really? Okay. All those are gonna be connected together. 3A, 3O, 4A, and 4O are all gonna go to ground. So we said 4. Okay. Where are the Y's? Is the Y connected? No, the Y is not connected anywhere. We're gonna ditch the Y's right now and the A's. These are all going to ground with this one. So you go ahead and grab these. Just do a nice little, not really nice, but all right. Let it pass. There you go. Beautiful. Awesome. Is to learn pub design? You mean PCB design? I don't understand here. I second on the CNC. All right, we'll do more CNC stuff. I also want to do some other projects like with the CNC stuff, like okay, drone related, but also some, maybe I want to do a nice carbon fiber stand for my PlayStation 4. But when I think about it, I think it's stupid unless I do some TPU along with it, because the carbon fiber is just going to completely annihilate the plastic on the PlayStation. So yeah, it'll take time. Designing takes a lot of time. A lot of time. All right. So O2, do we have anything on O2? O2 is actually connected to ground also. I didn't know that. So we're just gonna, we'll leave it for now, but we're just gonna put something here so we know that we didn't screw up. All right, let's go ahead and grab something. Grab this one. Okay. Okay. Put that there, and we're gonna put this guy here. Now these are not 3.3 volts, but it's just much faster. So O1 is SS, whatever that's gonna be, and then we have A1 or 1A is gonna be Miso. Okay, and we have A2. A2 is gonna be the initial int. Put them. Yeah, they look like this. All right, beautiful. Peppercorn. Yeah, the Mamba stack is from Diatone. You didn't know that? Mamba is nice. It's like a bridge between budget and premium. And lately they've been pushing more towards the premium. So they're nice stacks. I mean, I think this one has a Mamba. What the hell does this one have? Yeah, this build is still running the Mamba 20x20. I don't remember if this was the F7 or F4. I have no idea. And it has the best camera on the planet, which is the Runcam Split 3. The best HD recording camera, in my opinion, till this day. I didn't like the 4K Tarsier. It just felt like one of those Chinese cameras, these action cameras that you can buy, really. All right. So we have those basically done here. We don't need that one. 2Y is going to initialize. No, it's not going to initialize, is it? ARD MISO. Okay, so 1Y is going somewhere. So this is going somewhere here. Okay. We're going to hit it with the ARD. Oh, shit. All right. There's Peppercorn. There's more than one Mamba stack. They have a ton. Like they have maybe I think 3 20x20s. They have I think now 4 30x30s. I think they have their old. Yeah, they have quite a lot. They have F7s and F4s. So there's a couple of them. The Mamba is kind of like the model name of the. It's not the full model name, but it's part of the model name. And then it goes into whatever it is. For example, the Mamba DJI or the F405 DJI, that's one that was also a Mamba. But I don't think there still has been. I think that one's gonna be released maybe next month with all the things that's going on in China right now. All right. So this one we're gonna come back. VCC. What does this take for VCC? What the hell? This doesn't have. Oh, it's 5 volts. Okay. Okay, we're just gonna go here, grab this one. Let's say 5 volts. So we finished this one right now. Later on, we'll figure out how everything connects, and we can always double check with the board that I have here. So now we're looking at the 74A HC, which is this one right here. So okay, so we're gonna need. I'm just gonna draw these. That's all the O's are going to ground. So it's gonna be kind of dirty. All right, do this like that. Do this out here, and then all 4 of them. All 4 of them go in the ground. Okay, this one. Ooh, that's not a O. This one's O. Okay, all these are going to ground. There we go. So, this. Bam. Some people don't like when I do it like that. When I put them sideways. We'll do it just for them. Okay. All right. Just wanted to see the how many people are actually still watching. And again, if you guys have any questions, just feel free to write. All right. So what's next down the line here? We're gonna need. I'm gonna just bring this. I don't need to. Oh, maybe let's just bring it here. So we're gonna need. The Y's are going to S clock, SS, MOSI, and MRST. That's reset. Okay. That's the bridge there. 2A. So basically, I wasn't even using 2A unless it was bridged here because on my board I don't have any of them bridged. So we'll do the ARD S clock first on 1A. ARD S clock. You're gonna have to wait a bit because I don't have a micro USB next to me. Remo. This is USB-C. I don't have one right now next to me. Alright, just give me a second. Irvin, buddy, can you pass me a micro USB? Thank you, buddy. Oh. Yeah, just give me a second. I'll plug that in for you. What are you looking for? What exact settings do you need, Remo? Let me see. No, this USB-C. That just this wire. That's all I needed. This one here. Yeah. Awesome. Which setting did you need? Oh, is it stuck? Am I still streaming? Yeah, I'm still streaming. Imagine it didn't work. That would be funny. I was just talking about, yeah, the Mamba still works, and next thing you know, the shit doesn't want to boot no more. Let's see, 4K Beast, that's its name. So here's how this is set up right now. All right, I'll just give you the dump. Okay. Here's the dump file, and let's see. Okay. All right, let me just pass you the dump file here. Save it for you. Diatone.txt and text. I don't know where I should send this to you right now, but desktop or should I save it under videos? Thank you, Fly. Thank you, really. All the same. Okay, Remo, I just gave you the dump. Now, I don't know if you know how to use it. What you do is you'll log into your hold on. You log in just like the hold on, hopefully you can see what I'm saying. Wait, let me see. Okay. So you log in basically like this. You go down here to the CLI, and then right here you copy all of this. There's going to be a text file. You just Control-C everything, and then just paste it in here. Press Enter. Now I'm hoping you have the same the same version of the flight control. Now the version that I'm running here is Betaflight 3.5.5. So make sure you write that down now on a notepad. And the Mamba F7 here, 3.5.5, yeah. And just email me. Were you the one that emailed me? No, this is not you. Email me. I need the subject. I need the dump. And that's it. You know, that sounds funny. Yeah, just email me that, and then I'll know. I'll just reply with the attachment here once I get off the stream, and that should be good. All right. So now we're gonna continue on this. Does it pay off to learn? Do you build like 5 or 10 of them once versus buying Mamba FCs? Is it cheaper and worth the time? Well, it's it can be cheaper, but what's really awesome about it is you will learn a lot, like a lot, and everything will start to make sense for you, and you'll be able to diagnose and fix problems. What's really useful, in my opinion, more than anything, is if you're able to get just broken boards that just need a simple resistor fix or a simple microcontroller unit fix. For example, you'll be able to know. For example, here's a nice example. Okay, someone donated the board to you because the USB doesn't work. Okay, it gets power, it turns on and everything, and it flies, but you're unable to connect to it, and it's the F4 microcontroller unit. Now the F4 is very important here. So the only thing, or the only issue would be, hopefully this is best case scenarios kind of, but usually this is kind of thing, is there will be 2 resistors, kind of exactly what we see here. For example, let's go take a look at here. And I'll show you, I have the schematic right now. You have the D plus and the D minus. Now on an F4, the D plus and the D minus go to a 22 ohm resistor. So these are in charge of the, setting up the communication speed, if it's a high speed bandwidth, blah, blah, blah. It's just a protocol of the USB. Anyways, one of these could be bad. It would have infinite resistance or zero resistance, something like that. Then if you replace that with a 22 ohm, bam, you have a flight controller that's perfectly fine. So that's the kind of things you gain from it. Now, building it, is it cheaper maybe in the long run? I mean, it can be if you build one and you assemble it. You order like 10 pieces assembled. That would probably, depending actually, it could cost you anywhere between maybe $100 to $200. But that's basically $20 a board or $10 a board. There is a really nice thing where you pass or a limit when you pass. It'll actually be much cheaper. But they're all basically identical, really. All you got to be careful of is the firmware. So when you design with the firmware in mind, because the firmware dictates what pin of the microcontrol unit is doing what. For example, you have a Matek and you have a Mamba. They both have different firmwares. And the only thing that's different is pin 1 on the Mamba is for motor 1. And on the Matek, pin 1 is motor 4. You see where I'm going with that? So design with the firmware in mind. Check out, there's just two files in the firmware that tells you which pin does what. And just go on that. It's just like in one file. It tells you, this is SDA SCL, this is the buzzer, this is the LED. And again, you can also do the resource remapping and fix that later on. So that also works. But keep that in mind when you're doing your own from zero. For example, mine is different because I forgot what firmware I went on, but I have it written somewhere. I have no idea where I went. So let's actually take a closer look here. So this is what I was talking about. This is the micro USB on the on this one. Like right now, this little brand new F405 loop from Flywoo. If we follow the D plus and the D minus, we'll find that there's two 22 ohm resistors. But good luck finding them. I think they're on the back side here. I think those are it right there. No, I think those are for the... Anyways, but yeah, this is exactly what I was talking about. This is something very simple to just for you to know here. So you build around your firmware. Yeah, pick a firmware and build around that firmware. Now, also recommended you do, just to confirm that you've got the correct layout, is see what flight controllers you have that are working around you. And that's a nice way to cross-check and also see if you got everything correct, And you'll have to pull up the microcontroller unit, just the data sheet basically, because it'll tell you the name of the pins. Like right now, here's actually a perfect example, obviously. This is an open hardware flight controller right now. And what we see is, this is the STM32 F405. We see that you see the PA1, PA2, PA3. This is exactly what their names are in the Betaflight firmware. And where was I going with this? I kind of lost myself. And where was I going with this? You lost me for a second. Yeah. So for example, P8 is going to the buzzer, PA8. And you'll be able to cross-reference that with that same already pre-built flight controller that you have. You could go and find pin number 41, which is PA8, and see if it's to the buzzer pad or not. And that's a really nice way to cross-check everything. To check what you're doing and make sure you got everything correct. That's what I also did when doing this. It can get really complicated really fast, especially the OSD is just a nightmare. But yeah, I actually got this to work on my first try, which is insane. I even have a video on that. I was so happy. I couldn't believe it was flying. But when I went for my second design with an on-screen display, it was just terrible. It didn't work. Because it still needs more time. The OSD kind of complicates things. It's the way it's made, or the things you have to do to it is quite a lot. Lewis, say hi to your dog. Mr. Fly, I'll also send you the dump. Just oh lol, I need the dump. Yeah, I need the So build around your firmware. Yes, yeah. Design for the target you want to use. Correct. You could even, like, later on, you could even put different 5-volt regulators on the same board. You just find the same footprint and you could put a better one that could handle more current. F7 Fusion 20x20 that put the pins in backwards for AC pigtail and don't get any power now and don't want to pitch it. Lol. I don't know where you're going with this, Justin. Brain fart. Exactly. It was a brain fuck, really, not a brain fart. I run motor 2 on LED pin. Now, there's something you need to take into consideration when you do run a motor on another pin, which has to do with the internal clock. I remember there was something, but I don't really remember. Don't take my word for it 100%. But I'm fairly certain, like 60% certain, you have to be careful what you run because some things won't run properly because of the internal clock, or what is it called? Is it called the clock? The oscillator or clock? The hell was it called? I forgot. The interrupts. There we go. The interrupts. You got to be careful because some things, some pins are connected into a specific interrupt that can call. It's kind of like a clock that runs every specific amount of time. To kind of sync in with the PID loop and some other things also. I don't want to get too complicated in that because I don't have everything memorized on the STM32 microcontroller units, but I know that there is specific things where you can't put a specific pin to work for the motor because of the interrupt. Because obviously the motor outputs have to be in sync with the PID loop and the not just the PID loop, basically the PID loop. So you got to keep that into consideration here. Oh, thank you, Justin. That's really nice of you, actually. I need all the support I can get, to be honest. See you, Lewis. Take care, buddy. All right. So, where are we now? You guys are the biggest distraction ever. But obviously, I do this for you guys. I think I'm going to turn off my camera for a second because I really want to smoke a ciggy, and I don't want you guys to see me smoking. Or the YouTube algorithm to see me smoking. I put the power wire pin in the motor pin spot for the ESC stripe. Justin, it's really hard for me to understand what the hell you're talking about. The best way to do this is take a detailed picture and draw like a red line and a black line connecting and tell me what's going on really. That would be the best way to do it. Because I just don't understand what you're saying. I really want to help you, but I have no idea what the hell you're saying here. All right, so what do we have? 74AH, this one here. Yep. Okay, VCC is what? This takes 3.3 volts, unlike the other one. You gotta be careful. We can't just copy the other one exactly. Taking 3.3 volts. Oh, we don't want that. We want this. All right. So that we'll give it 3.3 volts. This is ground. Let's finish the ground now. Take ground. Where's ground? Here's ground. Okay. What else do we have? 1A. Where's 1A going? Just double check this is correct. You guys can see everything. Okay. All right. There we go. Center that for you guys. Okay. So here. Just want to zoom in a little bit more so you guys can see better here. Awesome. Thanks for understanding, Justin. Just try your best to do it in pictures because it'll just be so much easier. Like just put it in paint and just draw that, like a red line. If you have like a Samsung Note, just do that. Like with some people sometimes email me with a problem. I would just, take the pen out and then draw what they're supposed to do. Like, oh, bridge these two together and be careful of that one. It just makes it much easier. 1A is going to ARDS clock. So we need 1A. We're just going to keep it here. Y is going to the normal S clock. Okay. 2A is going. I don't even think I need this, to be honest. I'll double check that later, but right now I don't really feel like just pinning every single thing on it. The O's are all connected. We could ignore those. 2A. 2A is connected there. 4A is reset. Okay. What about the other ones? Wait. 4Y. Where's 4Y? Oh, okay. That's connected somewhere. 4Y. 3A and 3Y. Yep. 3A and 3Y. And 2Y is SS. Okay. I'm gonna put 3.3 volts. It's not 3.3 volts on all of these right now, but we'll figure that out in a bit. Now, okay, clean this up a little bit. Okay, out a little bit more. So what are we running on 1A? 1A is going to be ARDS clock. Okay, we're running on 1Y is S clock. Okay. 2A is SS, we'll just keep it right. And 2Y is also SS. So here I'm going to leave a note for myself. I'm going to put like a star, which means come back to it because I'm not sure what the hell that's doing. 4A is ARD reset. Okay. That was 4A. Get a little bit nicer here. Okay. 4Y is what? ST. Okay. And 3A is ARD Mosey. And let's see if you guys wrote anything. Is it okay if I use the capacitor that comes? Well, the capacitor is gonna have to go on the ESC. So hold on a second. I'm just seeing if I can find an ESC somewhere on me. What ESC are you using first of all? That's very important. Okay, and we have 3Y. Okay. So we finished that basically. Nice. Okay, we have, what is this? We have our other chip here. We have this one here, which actually we don't need 5 volts. Should we keep this? Oh, this is a 3.3 volt regulator. So we're gonna need a 5 volt regulator. Not only that, actually what we're gonna do with this board, by the way, is I forgot to mention earlier, is if you take a closer look here, let me see if I can show you that real quick. Okay. All right. So if we take a closer look at this board here that I've designed, it came with these pieces right here. Actually, I bought these. What you do is you install them into a PCB and you'll be able to put 18650s. Now, most of these modules run 7 volt-ish, but I need to confirm that. So what you'll be able to do is drop three 18650s and it'll power the whole module, which is really nice. And like this, it'll also do the 5 volt stuff and the 3.3 volt stuff. So it's going to be a really nice board. And then later on, maybe someone could help me 3D design something for it, or I'll probably do it myself. But if anybody would do that, that'd be super awesome. And then later on, you just bring in the module, connect it right on top, bam, and everything's working. All right, I'm just going to shrink myself here. Okay. All right, let's see. What do we have next? 3.3 volts. We'll come back to a 5 volt right later. All right, so I think what I'm gonna do now is just double check my GitHub page that I've created and double check what I did there real quick. So we'll say drone mesh GitHub, because I put the tutorial up on GitHub. Just finding it real quick. I have 20 repositories. Nice. USB joystick to PPM. Okay. Oh shit. Do I have it? Hold on. Oh, here it is. Channel number. Okay. I kind of forgot what I did. I'm gonna have to come back to that later. Okay, so we finished this part so far. We have the USB part. This is still unfinished, so let's go ahead and double check that, how that's going to be connected here. Let's see. Let's bring this up here. Oops. Okay, so here's the USB. So we have V bus, which is 5 volts. So it's going to 0.1. No, is that? Yeah. It's going to a 0.1 microfarad capacitor here. And here it's going to a 4.7 microfarad capacitor. Now what's really nice is I have the board right here. Oh, I should probably put the camera up and did a close up on that also. That would have been really great. Oh, so I see them right now actually. Let me see if I can show you guys. So right now what we see here on this right there, this is the female USB. And we have a 0.1 microfarad capacitor, and we also have a 4.7 microfarad capacitor. Now, how the hell are you gonna know which one this is? How are you gonna know this is the 4.7? Well, if you take a closer look at the capacitor, you see that it has a ground side and a positive side, and usually those will end up being a tantalum capacitor. And I just found them, and obviously they're gonna be here. It shows that they're right next to the USB part, and if we take a closer look here, sorry about my green screen, I'm just too lazy today. You can, well, it's gonna be difficult. That yellow one, and then there's another capacitor right next to it. It's those two right there, right next to the USB right here. So we found those 0.1, 0.4, 0.7 right here. So that's nice. And the other side's going to ground, right? Yep, it's going to ground. And the other side of this one, kind of see how it's going about. Where are they going at the end of the day? Going to this via right here. That's not going nowhere. Oh, that's this right here. So this is just a hole, basically. That is really weird, actually. Used here. Where is this coming from? Kind of. Gonna probably have to trace it. Oh, here's. Oh, I see a via. Okay, so V bus. Okay, so it's going here, here, here. And that's the positive side, but there's still nothing connected there. That's so trippy. Unless the pin is getting the V bus from 5 volts somewhere. Oh, yeah, that's how it's getting it. Yeah, okay, I see it now. Yeah, here's the V bus power. I see it now. So it's getting it from 5 volts. So we could kind of ignore this. We actually didn't need this here. And this is getting it from a 5-volt source here. Okay, so. All right. Okay. Remo F22 Mini. What's your ESC? What ESC are you using? Are you using a 4-in-1 ESC? What are you using exactly? So I know. Okay, so just give me a second here. All right. Can this pop out now? Still not working. I don't know why. Okay, so Justin, I'm gonna check your email right now. Just give me 1 second. One second to check it real quick. I don't think I got it. What's the subject you put? Justin, what's the subject you put? Here's Remo's. I need the dump. Okay, I got your email. Okay, let's see. Oh, okay, now I got it. Oh, shit. So you switched VBAT with motor 1, and you switched ground with motor 2. Is that correct, Justin? And now it's not working. Hmm. A little bit hard. I'm trying to think of a way where you can actually test it, so we know if it's actually still good. But it's pretty hard to kind of know right now. Oh my god, my green screen is so terrible. Should fix it. Let's see. I'm completely gone now. That's better, I think. Face is partly gone though. There we go. Yeah, I think this is better now. Yep. What could have happened, Justin, is well, I don't think the whole thing would die, to be honest. Well, unless you burn the 3.3 volt regulator. Send me a link to the ESC. Send me a link to the ESC, real quick. Send me a link to the ESC. And do you know how to use a multimeter? So it's gonna turn into a debugging video now. Send me a link to the ESC. Latency is really terrible here. Whoever's watching my stream and has an Instagram, come join my Instagram. It's pretty funny because I have the least amount of followers there than anybody else. Even the people that follow me have way more followers than I do. So yeah, if you want to support me, that'd be great. And also buy some merch. Why do you guys stop buying my shirts for some reason? Everybody stopped buying my shirts. It's been like a month with no sales, which is really bad. All right, let's see what you got here. Okay. All right. So, okay, I know how to use the multimeter. That's fine. Okay. Well, listen, check this out. The first thing you want to do is obviously I need the link. You need to send me the link. That's one thing right now. What you want to do first is just to check continuity between your VBAT and your ground. Just double check that. If it's beeping, then don't. That's it. It's basically screwed. Next thing you want to do is you want to test the 3.3 volt regulator. Because you know you could have, you still probably fried probably a lot more things than that. But there is a slight possibility that only the 3.3 volt regulator blew up because on the 4-in-1 ESC, all the microcontrol units, all the CPUs, they're all running off of the 3.3 volt regulator, and you probably maybe burned that one. Is a high probability, and maybe if you fix it, it might work. But at the end of the day, even if that was the case, I personally wouldn't trust that ESC anymore. So just buy another, basically. That's the best advice I'd give you right now, because it's not a joke. I'd fix flight controllers, but ESCs are just so unforgiving. You can still fix them, but they're just so unforgiving that it's better just to kind of use it for spare parts. You know, you take the FETs out, you keep them, because usually most of these run the same FETs. For example, the FET driver, they all these ESCs are using the same exact FET driver. So that's also a really good source just in case someday something happened. You could use that, especially on single ESCs. Yeah, all these ESCs and flight controllers. That's why you always see a 3.3 volt regulator. The microcontrol unit or the CPU or the brain of everything is always the STM32 chips. Basically, are always powered from 3.3 volt regulators. The chat won't let you. Are you on your phone, Justin? Probably. Just send me the name of the product. Which one is it? Which racer star? No problem, Stonewolf. Thanks, buddy. Awesome. Thank you for having me on Instagram. Not all of them. Some need 5 volts, but basically the STM32 is what we're using are all 3.3 volts. So sometimes the problem could be just a simple 3.3 volt regulator. See, for example, here we'll pull up my open hardware flight controller here. This is one without an on-screen display. It's using an MPU 6000 gyro, and you can see my 3.3 volt regulator here. And everything is powered. You have your gyro. Oh, yeah, that's not the gyro. My bad. Here. See, even the gyro. This is VDD is 3.3 volt on my schematic. So the gyro is taking 3.3 volts. The microcontroller unit is taking 3.3 volts. The what else is there? That's it, really. And obviously the F405. Now, there's something very important if you're going to be designing your own flight control, which I'd actually learned the hard way, and probably it was a very noob mistake that I've done, which is if you take a look at the pinouts of these flight controllers, you see that all of them says VDD, VDD. That means the 3.3 volts on all of them. And what I did was I didn't connect like 2 of them because it was just an absolute pain in the ass to do it on the schematic or on the PCB design part. And what it turns out is it actually needs every single one of those pins to get power, because it's like it has different computing logics within that each of them needs its own power supply. So that's something is very important, or else your flight controller won't boot up. So take that into consideration if you are planning on designing your own flight controller. It's very important you provide the 3.3 volts to every one of the VDD pads on the microcontroller unit. Very important you keep that in mind. It could be an absolute nightmare to have to redo the board, run extra traces after you had everything ran, and then once it comes to you, rebuild it with all these little tiny pieces. It's just pretty annoying. Also, something else to take into consideration. If you're planning on keeping the same form factor, then you're going to have to get the proper sized capacitors. For example, if you're going to be using 0805s, that might be too big to fit a lot of things. I think that's what I did on this one, my first one. And that's why I didn't even put a 5 volt regulator, because basically I had no space to do that. Let me actually double check what I did here. It's been so long since I've seen this. Okay, I think here's my PCB. So here's a PCB. Let's get a 3D view of this so we get a better idea of what was really going on here. So you can see here I use really big capacitors. I was using 0805s and they took so much space. On the back I didn't utilize the back, but to do this in a 2-layer board was just enough of a pain in the butt. And yeah, just keep into consideration your size of components that you're going to use for the resistors and for the capacitors. 0805, maybe some of them you might have to go big because of the capacitance. But yeah, just keep that in mind also. So Furkan, what I'm doing here is well, right now I'm showing I've done this before. I've done this video on how to build your own flight controller. Right now we're just discussing a couple things, but the main idea here is what we're building is basically a device that'll allow you to control your quadcopter with a USB joystick. So you'll be able to use like a TBS Crossfire, connect it to it, or a multi-protocol module, connect it to it, and you'll be able to use any joystick, for example, a PlayStation 4 controller, Xbox One, Xbox 360, whatever you want. So It has a lot of really good use cases for some people. Actually, it's not. I mean, look at this. Making your own flight controller is not beyond anybody, really. Look how simple it is, okay? Once you open the Betaflight firmware, okay, you find which one you want to go by. The reason why you do that is so you know the pins on the microcontroller unit are programmed to what? For example, PA8 here is buzzer. Oh shit, you guys can't see it because of my big ass head here. Okay, there we go. So, for example, PA8 here is the buzzer. Actually, let's bring up Betaflight here. Okay, so we're gonna say beta. Let's get into the flight controller part. I think that's gonna be really useful for a lot of people, so you can understand this a little bit better. So here, let's go into Betaflight. Here, we're gonna go to, I think, source, if I remember correctly. It might take me some time to find it because I forgot where it was. Target, I think. Yeah, there we go. So Betaflight source main target folders, and let's pull up. I don't know. Let's pull up something everybody knows. Here's the Maytag F405, for example, and I think it's the target C. Nope, not this one. Target H. Yes, there we go. Okay, so build your flight controller based on the target. Based on the target that you want. So, for example, here's a Maytag F405 target here, and it says the LED 0 pin is PB9. So keep that in mind, PB9. And if we come here, we could find PB9. PB9 here would be LED 0. So LED 0 is you know, when you put a USB in your flight controller and it has LED blinking telling you that it's on, that's what the LED 0 is. Let's make this a little bit better here. So the beeper pin, or the buzzer would be on PC13. Now on mine, I did a different firmware and I forgot what it was. My buzzer was on PA8. You see that? Let's see what's on PA8 here. Maybe nothing also. Not all of them are utilized. For example, on the Maytag F405, the PA8 here is SDA. So it's the IC squared protocol, or I2C protocol here. Do you see where I'm getting at? So once you find this, and everything is here. Look, you have everything. UART1 is PA10. The RX UART1TX is on PA9. And it'll slowly start to make sense here. Once you get this, it's really simple from here, because you could go back here and just start doing that stuff. And later on, okay, so UART1TX doesn't need anything other than a pad. So you just put a pad and you route that to it, and done. You can have UART1, UART2. You don't need to do everything that's on the flight controller. You can just do what you need, you know? Now, one important thing is you're going to need this 8 megahertz crystal right here, which is usually that silver thing. Let's see, hold on. Maytag F405. Let's go to images, and let's bring this one here. Let's see this. Okay, no, this one's even better actually. So the 8 megahertz crystal, which is one of the main components, is this thing right here. That's the 8 megahertz crystal, which is this one right there, the 8 megahertz, which is just gonna go like this. Very simple. So you have your 8 megahertz crystal. You have the pads for just about everything. Okay. Then all you need is a 3.3 volt regulator, the MPU 6000 gyro, and if it's an F405, you're gonna need an S-bus inverter. And this is how you do an inverter on S-bus. So you got UART1 and this inverts it. I mean, okay, it needs a little bit of time to understand what an inverter is. It's not that difficult, but you'll get it. And that's it, really. I mean, it's really simple when you think about it. And for example, here on the USB port side, we have 222 ohm resistors. Now, these are very important because these will initialize the protocol, the USB protocol, to be used in order to talk to the flight controller. The manufacturing, well, when I did mine, the manufacturing is nothing. I had to basically build it myself. But to get the PCB done, which is I think right here, here's my PCB. Here's a 3D view of it. I just installed everything myself. Look how basic I made it. It doesn't even have a 5 volt regulator. I had to do a separate 5-volt regulator to power this thing. Yeah, if you're not using FRSky or Crossfire, you just leave out the inverter. You don't even need it at all. And I think that's what I did too. I set up the schematic for the inverter, but I actually didn't put the components for the inverter when I made the PCB, because I did it here. And I just stuck a FlySky receiver on there and just stuck it on a UART. And I was good to go. And actually, I do have the quadcopter. One second. Let me see if I can get it for you guys. Here it is. This is the one with my own flight controller. It's under the video transmitter there. It's going to be really hard to see. But maybe I'll make another video on it. But I built this all myself. Like, it's a really ugly square board, but it flies perfect. Like, it flies beautiful. It needed a tune when I flew. It was such a long time ago, and it was really cold that day, so I didn't even bother tuning it. It just flew. I was so amazed that it flew. It was the first ever design. So I left out a 5-volt regulator, so you'll need an external 5-volt source. At the time, I think I had the ESC being I think this ESC had a 5-volt regulator at the time. Yes, it was a Dalrc ESC with a 5-volt regulator, and that's how I gave 5-volt to the board here, and that's it really. And I just routed the 5-volt. So, for example, if you take a look here, I brought the 5-volt from the ESC, put it here, and these are all connected together. So I was able to put my camera here to get 5 volts. And that's basically the camera now being powered from the 5-volt on the ESC. And it was just very simple. Here I put a separate 3.3 volt because obviously this is a 3.3 volt regulator right here. That's supposed to power the flight controller and also the gyro here. Now, the hardest thing to do, or when you're building this or soldering this, is the gyro. The gyro is a pain in the ass. You have no idea. It's an absolute pain to put that thing inside. You know, I'm in the EU right now, but I don't think we can. I think when you do that, you have to put maybe it's your like social security number or some other thing. I'm not sure, but if we can, I was gonna make a dedicated video on that also. You know, to raise awareness, because that's really huge. What's really going on right now, and it's sad to see because our hobby has brought so many people, you know, out of shit. What I mean by out of shit is like I know a lot of people who've been, you know, because of this hobby, got them out of drugs, got them out of all this nasty stuff they were doing that was ruining their lives. And I also know a lot of people who are disabled, you know, like paraplegics who can't walk, and you know, some people just have other disabilities, and the only joy in their life was because of drones, you know, or RC stuff. It gives them something to do, something to concentrate on, even opportunities if they get good enough. And it's a shame what they're doing right now. It's all monetary. It has to do with money. Some big corporation is trying to get everybody out of the air, or trying to monopolize the drone components. But I think, you know, these people don't see the full picture like we do, because they look at DJI and they say, oh, the drone market is huge. But to try to destroy the whole drone market is just ridiculous. I mean, I don't know. To be honest, I think they should do that shit just to DJI stuff. You know, I like to use DJI stuff, but you know, our own built FPV quadcopter should have nothing to do with what the hell they're doing. I'm not trying to blame fingers, say no, it should be you, not us. But at the end of the day, it's usually because of those people and not because of us. Because I don't think any of us have done anything bad. However, I do think that, you know, I'm not putting anyone on spotlight or anything, but some channels, the places they fly, I think they shouldn't post, especially with their size, unless they have real permission to fly there, because those could really affect that whole situation. And, you know, like for example, I fly where I know I'm 100% allowed to fly. So I was flying in a field, I had a problem there, I stopped flying there. I moved on to my abandoned area when nobody's around. Nobody bothers me. I don't fly high. I do my own thing and I leave. And that's it. I don't bother anybody. I don't do anything, you know, that I'm not supposed to. I'm not trying to ruin it for everybody in my current country here. In Europe, to be exact. So yeah, just mind my own business. And I don't know, this thing is pretty scary actually. If I was back in the US right now, I would go to the DC protest, even though that really won't do much unless you get really good coverage. But you'd need to get like all the YouTubers to raise awareness, especially the ones that use DJI stuff. For example, like who would be one of them? What's that guy's name? Damn, I can't believe I forgot him. Casey Neistat, that's one of them. Should say something, since he gets a lot of drone shots, and that would affect him as well. So, yeah, that thing it's not a joke. It is not a joke. Also, for example, Banggood. Well, no, I wouldn't say AliExpress. Banggood, Eachine, Racer Star, GetFPV, Ready Made RC, DRL, DCL, all these people should, also put, raise awareness of, I should say, for what's really going on. What? That's crazy. A drone delivery of wine to his room. Justin, you see, I mean, this thing just brought a lot of people together, and it doesn't only, our current hobby doesn't only bring people together. You learn a ton, like a lot of. There's some things I never knew before. It just forces you to get out of your comfort zone because you have to. It puts you in these really shitty situations. You think they're shitty at the current moment in time, but when you dig in more and more and more and more, you've actually benefited so much because of that issue. You might have lost maybe 100, $200, but at the end of the day, the amount of knowledge you gained is much, much more valuable than what you wasted or you thought you wasted when you actually didn't waste that. And people, like, after a while, they end up seeing that part. You have to screw up. If you don't screw up, you really don't learn anything. And some people are starting to get into designing. Some people are doing their own frames now. Some people never touched 3D designing, and now they're designing their own frames, and they're awesome ass frames. So it's a gateway to good, productive hobbies or even business opportunities. If you can't find a job, maybe some people. I'm pretty sure some people was able to create a job out of it and be able to support their families. And that's the side that nobody really talks about. Nobody really sees that often, but that's what it really does. For example, myself, this has done quite a lot to it's changed my life basically. So in terms of everything I've done, everything I've learned, the people I met, it's just been amazing. And I'm not saying I became super rich because of it. That's not what I'm saying. Just the amount of knowledge and the people I met is just unbelievable. And and I'm sure I speak for a lot of people when I say that. Just give me a second, guys. Just writing a message real quick. All right. So let me just catch up with your comments real quick. So you're getting a purple-ish flickering? I don't know what a purplish flickering means, to be honest. The first thing to do is try a different camera. If it's still doing the same thing, try a different video transmitter. If it's doing the same thing, then it could be electrical noise, possibly, or the regulator that's powering them is bad, unless it's taking VBAT. It's really hard to know, Esk, unless you send me a DVR recording. That would kind of help, hopefully. $400 for a plane ticket. It's not the money thing why I can't go right now. It's more of my son's right now on Monday, which is when's Monday? In a couple days, my son has his MRI scan, and after that, because he also still needs another surgery. He's my 1.5-year-old, and yeah, so it's more of family things that I have to deal with more than it's not monetary. I book a plane ticket and go. But I have to be here right now. So that's the only thing. That's the reason why I really can't go. Even if I get the money to go, I still won't be able to go because I got to stay with my son. What power VTX is legal in Europe? Well, Pablo, I think like 25 mil. I don't. To be honest, I don't know. I just fly 25. most of the time, all the time. I mean, all the time. And I just got my DJI goggles 2 days ago, and once you activate it, if it'll detect that you're in Europe by your IP address, and it'll just limit you to 25. So we know that 2.4 gigahertz limited to 25 milliwatts in Europe. 5.8 gigahertz, I think it's pretty much open to a specific amount, but I'm not sure. So Cenobite says, a few years ago, I didn't know how to solder. Now and ready to start making my own flight controls. I'm 3D printing daily. I'm working with this SOD and Sonic model designing wings for FPV. Crazy. That's awesome. Good luck. Okay, music production. Awesome. Thanks, Cenobite. Okay. So where were we? You guys lost me. Maybe we should go back and touch up on the flight controller a bit. So for example, here we have a Maytech F405 OSD. And I'll show you similarities, like really crazy similarities here. Every flight controller is basically identical. There's nothing that makes a flight controller better than the other, except a couple things. For example, feature set, 9-volt regulator, 8-volt regulator, LC filter. These things, or pit mode, dual cameras, those are the only really differences between flight controllers. Now, back then, I don't know if people were still around, Maytech released F405 all-in-one CTR. It had the ICM gyro, and everybody had the twitch of death, we called it, or I called it. I don't know who called that, but I think it was me. It was just twitching like crazy. It was high on crack or something. Now, the problem with, I still don't even know. I still have one. I haven't really figured out what the problem. I think there was a lot of noise hitting the gyro, or the way that the traces were laid out was bad. And Maytech took a big hit on that one. And eventually, I guess they figured out, whenever you're in doubt, I say always take a Maytech because they know what the hell they're doing. But I remember that was one of their biggest flops that was an absolute nightmare to them. But they've only had one. Other than that, everything has been beautiful. But, the thing is with flight controllers, they're all identical. All of them. Even the super cheap ones, they're basically identical. Some components might be cheaper than others, like a regulator. But at the end of the day, these are not going through a lot of stress. Unless, you get it's still very difficult. They're both basically identical. Just a regulator, microcontroller unit, a gyro, and the overall layout. So you can get by with something really cheap and really simple. It doesn't have to be super expensive to be good, Unless, like for example, the Mambas that have the F7s and they have the 9-volt, 5-volt, 3-volt, and they have like a dual camera switching. Then those are really nice to have, But usually all flight controllers are basically identical, really. Furkan 10. I don't know how to say it. I'm just gonna call you 10 Sky. 10 Sky. What question were you? What's your question? I don't know your question. Maybe I missed it. Let's see if we can find your question here. I want to buy a Mamba flight controller for 40. Can I make my own FC and ESC? I don't know if that was your question or not. But to be honest, if that was your question, just how much do you smoke? Maybe 10 to 16 a day, depending. Not packs, ciggies. Oh, you had to remind me. No, I need one. I'm trying to get sponsored by Marlboro. That'd be nice. Then I could concentrate on my DIY projects while we smoke on stream. See, I prefer to get sponsored by nothing that has to directly do with what we do or the companies that we work with. For example, I like PCB Way. That has nothing to do with drones, okay? But I love their service, and yeah, it's not really it is kind of like a sponsorship. And it's really nice to look at that way. Like I want to try to get a coffee sponsorship or a drink sponsorship, and that really doesn't influence anything I do, you know. And I really like this is the mentality that I'm aiming towards here. Let's see. Is there a best gyro yet? Well, listen, Cinnabite, there isn't the best gyro. It's what we're limited to through the software side. So right now, Betaflight, you might as well just stick with the MP6000 gyro. Everything's been flying great on that. You have Flight 1 and the other ones using the super sensitive gyros, and they're doing pretty great on that. But at the end of the day, actually, most of these are actually pretty useless, depending on the ESC protocol you're using. Because you have to be able to update the motor as fast as the information that's coming in. And there's also a limit in terms of how fast the physical thing could move or switch its position or orientation or rotation, I should say. I'm currently ripping apart my Pixhawk S500 build, having issues with the VTX2 and a couple other minor things, trying to troubleshoot it now. All right, guys, I think we're going to call it a stream because I'm getting a bit tired right now, and I still need to create a video, which is this one here, this one. I just need to make the setup guide for, what is it called? The Flywoo 16x16. So I got the Flywoo 16x16 here, and I need to make the video for it still. So it's getting late right now. It's like 7 p.m. here. It's really nice. I don't know if anybody's seen this, actually. I love what they've done with the video transmitter. This thing will fit 30 by 30, 25 by 25, 20 by 20, and even 16 by 16. It's crazy. It is absolutely crazy. It's a whole stack comes with the VTX. And you get this really beautiful little ESC. I really like it. And see, with this ESC, they're not doing the same thing they did with the all-in-one board here, actually. They give 2 FETs for each phase. Is it 2 FETs for each phase? No, actually, no, it's not. Or is it? Wait, I can't even think anymore. No, it's actually, oh, fuck. That is really weird. It's supposed to be 2 FETs per phase. So 1, 2, what is this? 6, 12, 3, times 2, 6, 12. Yeah, that's correct. Damn, I'm just having a huge brain fart right now. That's how tired I am. Anyways, it's a really nice flight controller or stack. Or the design is really nice. These are going on builds very soon. I actually scrapped the frame that I was going to use because it turns out it was an exact clone of Kebab's, which was this one. I had no idea. So yeah. Maybe I'll just design and cut my own. I think that's going to be more interesting. And should be good from there. I think that's what we're going to do here. Yeah, you're right. 12 is 1 for each phase. 3, 3, 3, 3. Yeah, you're right. You're right. Yeah. Thank you, Kumar. You're correct. Yeah, they're doing exactly the same thing on the IO. Like I said, 1 FET per phase. Because we have 12 pads, 3 each motor, 3 times 4. Because we got 4 motors, 12 FETs. It's 1 FET per phase. Yeah, it can be a bit of a brain fart, especially when you're getting sleepy. Yeah, I think it's a dual channel or something. It's really actually, I never noticed it before. I noticed it, I think yesterday or 2 days ago was the first day I noticed it. I was like, wait, how the hell do they have this many FETs? I was holding this one. I never really looked hard at these boards until I noticed it. And I was just like, it's like a dual channel maybe they're running here. That's pretty cool though. I really like that. I really want to make my own. But I had I did also an open hardware ESC design with a BB2 chip, but that was a fail. I need to do it again. And also this board here, it's a dock for modules. It has a lot of noise in it, and I haven't debugged it yet. And but it's already basically built here. I haven't finished the second video of it though, but we'll come back to it when we get a chance. Nice, Kumar. Awesome. what I meant is I didn't know that they did the dual channel on these boards here, which was what I recently figured out. It's really nice though, really really nice. Oh yeah, this one has the barometer. All right, guys. Well, let's call it a stream again, and thank you for being around. And I'll have videos up very soon. And I took some notes on some of the things you guys want to see, like an intro into PCB design, a Whoop budget brushless build, and the emails I need to reply to, and also I'll do the let me write the F7. I think we'll start with a series on the F7, build your own F7 flight controller. I'm not gonna try to do it all in one video, which I think is the best way to do it. Not like my previous video. So we'll start off, we'll grab maybe the regulators first, and then we'll grab, next I'll show you how I grab a target from Betaflight, and we see which one we like the best, and we work our way from that. I think that would be the best thing to do here. We do it one step at a time, and maybe I split it into sections. Like today we're gonna be covering all the pads. Today we're covering the gyro connection. Today we're covering, what else is there? We don't need an inverter. The regulators, and maybe if you even wanted dual camera switching, we can add them into modules, which is what's really nice. Like this, for example, I can do it in a way that when you delete this part here, it'll basically take out the 3.3 volt regulator, which is really nice. You could like grab modules from there. And yeah, well, that's it, guys. I'll see you in the next one. Peace out. Thank you, Kumar. I just saw your message. Thank you. Thank you for supporting me. Buzz Cola, it's been forever since I've seen you. And peace out, guys. I'm going to head out now. Take care. Need to find how to end the stream here.